Okay, I'm going to start my test and let's see how this goes. I'm going to try and get a new preview. All right, here we go. I also have my dogs here with me and they might bark, so just to warn you. Okay, if we're just adding, then you can drop the parentheses. So nothing to see here if it's just straight addition, plus sign that separates them. Okay, and you want to combine like with like. So my highest power is x to the 7th. 9 plus 2 is 11. So those will go away. Then I'll have minus 8 x to the 5th plus 4. So that'll be minus 4 x to the 5th. And then I'm left with plus 5. And so that looks to be matching down here with the last one. And so I'm going to choose that one. Okay. Now, as you can see, we have a negative sign, a minus sign, a subtraction sign in here. There's nothing out the front there, so we can drop the first set of parentheses. But now this negative sign has to be applied to everything inside, not the first term, which is the common mistake students will make, only applying it to the first term. It has to be applied to everything inside the parentheses. So I'm going to get minus 8r to the 4th, then minus negative 9r cubed, so that's plus 9r cubed, then minus 6r squared, and minus negative 2r, which is plus 2r. Now I'll collect like terms. So those are my r to the 4th term, so I'm going to have negative 10 r to the 4th. And since this is multiple choice, there's only one that has that, okay? But I'll go ahead and do the whole schmeal. 9r cubed plus 9r cubed is 18r cubed. Minus 6r squared. And minus 3r plus 2r is minus r. Okay. And so our answer is that second one there. Okay. All right, now we're going to find the product. I might see if I can make this a little bit bigger. Okay. So we're going to have, this is foiling. So first I'm going to multiply the 2x by each of these. So 2x times 5x cubed is 10 x to the 4th. 2x times negative 2x squared is minus 4x cubed. 2x times negative 4x is minus 8x squared. And 2x times 4x is plus 8x. And then we multiply negative 3 by everything. And so we're going to have negative 3 times 5x cubed is minus 15x cubed. Negative 3 times negative 2x squared is positive 6x squared. Negative 3 times negative 4x is plus 12x. And negative 3 times positive 4 is minus 12. And so now I only have 1x to the 4th term. And you can see now you can't just decide on one like you did the last one. Now for my x cubed terms, minus 4 minus 15 is negative 19. So it's not going to be this one. So I know it's not going to be that one. So now I've got it down to those three. All right, for my x squared term, minus 8 plus 6 is negative 2. So minus 2x squared, so it's not going to be that one. And then 8x plus 12x is 20x. And so it's not going to be that one, so it's going to be this one, but just make sure. And then I'm left with minus 12. And so it's going to be that one. I'll choose that one. Okay. All right. Determine whether the relation represents a function. This is fine. This is a function. So we have our domain, and we have a range. And the thing of it is anything in the domain can only be matched to one thing in the range. So Alice is only matched to one thing, Brad is only matched to one thing, and Carl is only matched to one thing. It doesn't matter that Brad and Carl match to the same thing. So this is a function. And the domain is going to be the set on the left. So the domain is going to be Alice, Brad, and Carl, and the range is going to be cat and dog. So we get that. Okay. All right, now determine whether the relation represents the function. I'm looking to see if there's any repetition of the first entry. So if it's a function, then there's no repeats of a first entry as a first entry. So -1 is a first entry, and it's not a first entry anywhere else. It's a second entry here, but that doesn't matter. So -1 is not repeated as a first entry. +1 is not repeated as a first entry. +4 is not repeated as a first entry. And +8 is not repeated as a first entry. So this is a function. And so the domain is going to be the set of first entries. And the range will be the set of second entries. So the domain is going to be the set consisting of -1, 1, 4, and 8. And then the range is going to be the set of second entries. So that'll be -8, 4, -3, and -1. Okay, so that looks like this one here. So let me just, okay. All right, we have to be extremely careful here that we don't make a mistake with the negative signs. Okay, so let me get my pen back on. So I'm going to have 5 times b, and b is 16, then plus 10 over a, and a is -5, minus the square root of b. And even though it says c is equal to 7, I don't see a c anywhere in here, so I didn't use it. Okay. All right, so I'm going to have 80, and 10 divided by 5 is -5 is -2. And I'm going to have -4. So 80 minus 2 is 78, and 78 minus 4 is 74. So that's the one I'm looking for. Okay. All right, so if I'm going to find the value of f of 4, then everywhere there's an x in the equation, I replace it with 4 in parentheses. So it's going to be 16 plus 8 plus 4, which is going to be 24 plus 4, which is going to be 28. And so that's the one we want there. Okay. All right, find f evaluated at 1. So wherever there's an x, we replace it with 1 in parentheses in the equation. So I'm going to have 1 minus 8 over 1 plus 2. So I'm going to have negative 7 over 3. All right, so now we want to find f evaluated at 2. Well, what a function does is it takes a point on the graph of the function and it maps the x-coordinate into the y-coordinate. So f evaluated at x is equal to y. So now if we want f evaluated at 2, we find the point whose x-coordinate is 2. And here it is. So that's a point on f, and what f does is it maps the x-coordinate into the y-coordinate, so f evaluated at 2 for this one is equal to 5. So I want to put 5 in there. Okay, so now what I have to do for this one is when it's something a bit more complex than a number, let's rewrite the formula and just put blank parentheses instead of an x. And we want to find f evaluated at x minus 1. So I'm going to put x minus 1 inside there. Now, this is in theory a correct answer, but as you can see, none of the selections look like that. So I'm going to have to expand this. Now, the 2 here is going to stay on the outside. Now, x minus 1 all squared is not x squared minus 1 squared. It's going to be x minus 1 times x minus 1. Here I need to distribute the 2 through. So I'm going to have plus 2 times x and plus 2 times negative 1, which is minus 2, and then I have the plus 3. Here I'm going to have x squared, have to FOIL it, minus x, then minus x again, and negative 1 times negative 1 is plus 1. And I'll have plus 2x, and negative 2 plus 3 is plus 1. Now inside here, negative x minus x is the same as minus 2x. So I'm just going to save a line there. Now for the very last part, I'm going to multiply the 2 through. So I'm going to have 2x squared. 2 times negative 2x is negative 4x. And 2 times 1 is 2. So finally, I'm going to have 2x squared. And minus 4x plus 2x is minus 2x. And 2 plus 1 is 3. So that's what I'm looking for. And that's matching up with the first one. Okay. All right, now we want f evaluated x plus 1. So again, I'm going to rewrite this formula, and I'm going to have blanks instead of where the x was. And now inside, I'm going to put x plus 1. And again, in that numerator, x plus 1 all squared is not x squared plus 1 squared. It's going to be x plus 1 times x plus 1. And in the denominator, these parentheses don't matter, so I can just drop them. Okay, so if I FOIL this, I'm going to have x squared plus x, and then plus x again, so plus 2x. And then finally, 1 times 1 is plus 1. X plus 1 minus 4. 1 minus 4 is not minus 3. Okay. So I should be having minus 3 on the bottom, so that one I can at least rule out. And then finally, I'll have x squared plus 2x, and 1 minus 8 is minus 7. Okay, so that looks to be that one there. Okay. Continue on. Okay, now what is the domain? Well, we have a fraction here, and the denominator is not allowed to be 0. So let's do that a bit bigger. But this is the restriction on 2x plus 10. For the domain, I need to know what the restriction on x is. So subtract 10 from both sides and divide both sides by 2. So x can be anything except negative 5. But it says to write your answer in interval form. So if you don't know how to write that in interval form, then if we think about the number line, and if that's where negative 5 is, then x is allowed to be anything except negative 5. So anything in the red. And if you read that off from left to right, you'll have minus infinity up to but not including negative 5. Then you got to jump over it. And then once you've jumped over it, it goes on forever. Now, it did say to write inf if you're going to type this in. And it did say do not type any blank spaces, because Canvas will, if you have like A plus B without any spaces, and then A plus B with a space in there, Canvas will count it wrong. It's really bad, Canvas is about that. All right, so I'm going to type in minus infinity, INF, comma, negative 5, no spaces, and then a capital U, no spaces, then negative 5 to positive infinity. No spaces, like it said. Okay, so that's what I'm going to enter in. All right, now what's the domain for a square root function? Well, the domain for a square root function is whatever's inside here can be at least 0. So whatever's inside, the argument has to be greater than or equal to 0. Now, that's the restriction on 3x minus 6. What's the restriction on x? Well, add 6 to both sides. That does not change the direction of the arrow. And divide both sides by 3. Dividing by a positive number does not change the direction of the arrow. So that's my domain. The domain is the x values that are allowed. But I have to give the answer in interval form. So again, what would this look like on the number line? If you don't know how to write that in interval form. So I would start at, and I would include 2. And then the arrow's pointing to the right, everything bigger than 2. All right, and so what I have here, if you read this from left to right, I start at 2 and 2 is included, so I have to have a square bracket, and then that goes on for infinity. So if I'm going to write it in here, I'm going to come here No blank spaces, so square bracket 2, comma, and no spaces, INF, and then a parenthesis. All right, now we have a square root, but it is in the denominator of a fraction. So we have a double restriction there. Because it's a square root, what's inside can be greater than or equal to 0, but because it's in the denominator, it's not allowed to be 0. So with those two together, this is our restriction. Okay. Because it's not allowed to be 0 since it's in the bottom. And I have to get the restriction on x. So add 15 to both sides and divide both sides by 5. And here x is strictly greater than 3. And if you were to look on the number line of what that would be like, you would start at, but you would not include 3. And then you'd want everything to the right of 3. And so if I was going to write that in interval form, I'd start at but not include 3. And so I come here and I'm going to start at but not include 3, so it has to be parentheses, and then it goes on no spaces, INF. Okay, let me continue. Okay, so which one is not a function? This one is not a function. This one down here in the lower right, because it fails the vertical line test. I found a vertical line that goes through it more than once. So that one is not a function. And that's selection D. Okay. We're going to give the graph of this. What is f evaluated at 1? Okay, so remember, if you have a point on the graph, so if that's a point on the graph, then what f does is it maps the x-coordinate into the y-coordinate. So what is f evaluated at 1? I need to find the point whose x-coordinate is 1. So here's 1, and we can see there is no point on the graph whose x-coordinate is 1. So there's no point with x-coordinate 1. So f evaluated at 1 is not defined. And so we're going to type in D and E. Okay. And no spaces, just D.